What's up, guys? Today we're going to do a quick coding challenge that you might hear about in interviews or in an algorithms class in school. So we're going to focus on the common Fibonacci function, which is a common recursive. So it has a common recursive and dynamic programming solution. So we're going to start with the more brute force solution, and then we'll move into more optimal solutions after that. So if you want, you can give this a shot first and then come back and watch the video. So I guess the problem would be, given the Fibonacci sequence, where you start with 1, 1, those are the first two starting numbers, you have to reach the next numbers are always the sum of the two previous numbers. So 1, 1 gives you 2, 1 and 2 gives you 3, 2 and 3 gives you 5, 8, 13, and so on. So we want to write a function. We can call it fib. We pass in n, and n will be the number in the sequence that you want to return. So given fib of 0, 1, 2, we'll return 2. So we could write some simple test cases to make sure our function is going to be working before we even start writing it. There's more of a test-driven approach to writing this. So we'd say fib of 0. We say fib of 1, so we'll do a 1 index based solution. So fib of 1, we could say is equal to 1. Fib of 2 be 1. Fib of 3, 2. Fib of 4, 3. So those are just some examples just to test our logic here. So our function, we're taking an n, and we're going to return the actual value at that index. So we could start by, I guess, a more brute force solution would be to keep a value of an array of values of all the numbers in the sequence that we've seen so far. So we'd say, like, while values.length is less than n, values.push values, and we should probably keep a counter here. So we'll start this with, we could actually initialize this array with the first two ones because we know that those are always going to be true. And then we'll start this with 3. So values, this should actually be, because our array is going to be 0 index based. So 0, 1, and then 2 would be the next number we're going to push in. So values I minus 2 plus values I minus 1. So while the values, the count of values in the array is less than the number we're trying to find, we're going to add that value to this values array. So 2 values ago plus 1 value ago, sum those together, and that would be our new value going along with the Fibonacci sequence. So given that, let's just log out our values and see what we get. So for n, these are our values. So we could see for 1, we want 1, and we got an array of 1 and 1. And then for 2, we wanted 1, and we got 1 and 1. And then for 3, we got an array of 1, 1, 2, which looks correct, because that would return the third value, which is 2. And then for 4, we have 4 values in the array. So after this, we could just do a return values dot, either values dot pop or just do values dot length minus 1 to return the last value in the array. And you can see one of the assertions did fail, so let's see which one that is. So if we print out what these are, see, we're getting let's log this instead of asserting. So I'll turn this one off too. So we got a 1, 1, 2, and 2. So for 1, we wanted 1. we wanted 1 again for the second one. For 3, we're looking for 2, and then for 4, we're looking for 3. So why in the last one do we get a 2 again? So it looks like here on the when it's added this last value here, so it looks like there is a little bug here. So what we have to do is just increment I, and that will solve our problem. You can see it is working now. So our assertion should all be working. So for the last case, we have 1, 1, 2, 3, which is the beginning of the sequence. Okay, so this is a good brute force solution. We could add a couple other ones just to see how they are. So we could add these assertions back in just to test our code as we're writing it. And this would be 1, 1, 2, 3, 5. So we have some test cases. Those are all passing. And this is a good solution to start with. If you're in an interview, you could say you want to go through your logic and what you're thinking about. And you'd say this is a good solution. It's going from, you can talk about the time complexity, memory complexity. In this case, we're storing n values in this array. And then you could talk a little bit more about that and your thinking behind it as you're going through and coding it as well. So how can we make this more performant or just cleaner in general? So this, as I mentioned in the beginning, this is more of a recursive solution, or like a common solution is usually using recursion. So how can you think about using recursion for this function instead of having a more iterative approach here with this loop? So if you want, you can go ahead and try that out. Try using a recursive solution instead of our current solution here. All right, so if you gave that a shot, let's go ahead and see what we could do. So as you might notice, we're pushing in values I minus 2 plus values I minus 1. And if you think about it, what we're trying to actually return is the Fibonacci of n minus 2 plus the Fibonacci of n minus 1. Because for example, if we want n of 5, which would give us the value 5, we're looking for the previous Fibonacci, so n of 4 plus n of 3. So how can we use that? So instead of having this, we could remove all of this and then say return fib n minus 2 plus fib n minus 1. Let's try running that. So maximum call stack size exceeded. So this could be a kind of a border case. So if you're passing in fib of 1, what's going to happen is you're going to be looking for fib of n minus 2, which would be negative 1. So in that case, it would be invalid. So we can just do some simple checks here first. So if n equals 1 or n equals 2, return 1. So if we run that, you can see all of our test cases pass. And as if you could tell from before, it's a lot cleaner solution and is less code and also just easier to kind of follow. So you could see that fib of n is just the sum of two Fibonacci numbers ago and plus one Fibonacci number previous to this one. Okay, so this is pretty good so far. Let's remove these assertion statements and let's try something different. So we're going to do a console.time if you're in JavaScript. If you're in a different language, all we're going to do is kind of wrap our function execution call in a timer so we can see how long it actually takes to execute. So you could do something similar in whatever language you're using. So we can say console.log fib of, let's say 40, and console.time end. So if we run this, let's see what we get. So it took 1 second to run. So you can see as the numbers get higher, so if we do 30, a little bit lower, 30 is pretty quick, but then when we go to 10 more than that, 40, it's more than double the time to run. So let's do a couple of test cases here. So n equals 40 time, so we have so far 1.026 seconds. And then we just got one for 988. I'll put this on milliseconds. So 1026, 988. And let's do one more test. So we got 994. Okay, so this is, let's say, without optimization. So let's try to optimize this function a little bit to make it run faster. So this is going to be a common interview question where they're going to say, okay, this is good, but how can you make it faster? Because you don't want your customers having to wait multiple seconds. For example, if they're asking for fib of 60, you can see it's going to hang on there for a little while, and we're not sure how long it's actually going to take. So one common way of improving a solution like this is to use dynamic programming. And what that is caching values that you've calculated already to avoid having to calculate them again. So what we could do is just create a map or a dictionary. So a map will have very fast lookup times, so that will allow us to store values and then look them up quickly when we're looping through, instead of having to recalculate them again, which, as we can see from our tests, it took a little bit of time. So we can create a new cache. In JavaScript, you can create a hash map just with by creating an object, and it'll create the hash keys and everything for you. So this is our hash here, and in our code here, we could say if n equals 1, n equals 2, return 1, else we have this. So nothing's changed yet. We're just cleaning this up a little bit. And here, before we return this value, let's just store this in a variable. So we'd say fib value equals fib of n minus 2 plus fib of n minus 1. Let's add this to our cache. So for n, the value that we're calculating, the Fibonacci number 4, is going to be equal to fib value. So for that n, we're going to store the value associated with it, and then we'll return that value. So instead of just returning it, we'll cache it and then return it. So if we run this, it should all run the same. We still have 60 on, so I'll keep that down and let's run it again, because the 60 is going to take a while. So we're still around the same time, maybe slightly longer, maybe just because we're caching value, so it's an extra step. So now that we have this cache, we might as well use it. So we're going to check to see if n is 1 or n is 2, return 1. We can add an else if here. So else if the cache contains the number we're trying to find. So if we have that number calculated already, there's no point in recalculating it again. So if the cache contains n, let's return the value for that we calculated previously. So if we run this, look how quick that ran. So it's under 10 milliseconds, where before we're almost over a second. So let's add these numbers up here. We're going to do some more trials. So 9 milliseconds. Turn it again. We got 10.4, and then 9 again. So you can see there's a massive improvement by using something like dynamic programming for your solution. And this would be more of an optimal solution if you're in a coding interview, or if you're in an algorithms course and they're asking you this on a test or something. So yeah, doing stuff like this, if you're in a coding interview, make sure you talk about you're thinking through the problem. You could even think about, like, you'd say something like, yeah, I know this is kind of a brute force solution. This is what my initial thoughts are. I'll code this out, a kind of basic framework, and then we can kind of improve it from there. So that's kind of what we did. We start with a high level naive solution with we had the while loop in the beginning, and then we kind of broke it down and optimized things as we went, as we found areas for improvement in our code. So if you have any questions, feel free to leave a comment or send a message to me. And if you like this video and you found it helpful, feel free to like it and subscribe to my channel. Thank you.